What if we are given a complex number z and we are asked to find the inverse of that complex number? Paano natin yun kukuhanin? Okay, so now, we will derive an expression for finding the inverse sign of a complex number z. So, since sa simula, hindi pa natin alam kung saan equal ang inverse sign nung z na yan, we will let it be equal to x. Okay, so unknown pa yan. So, thus, the goal here is to solve for this x because that x is the answer to the inverse sign of z. But since we don't know yet the expression for finding the inverse sign of z, magsimula tayo dun sa alam natin. Okay? Ang alam kasi natin, yung expression sa pagkuha ng sign. Right? We know that. So if I get the sign of both sides, sign of inverse sign will give me the original z. And on the right side, makakaroon ako ng sin x. And since we know the expression for sin x in terms of the complex exponentials, gagawin natin yan. Ano? This z is now equal to, again, the expression for sin x in terms of complex exponentials is e raised to jx minus e raised to negative jx over j2. Now, what are we going to do? To simplify this expression, imumultiply natin both sides of the equation. No? Ano ang gagamitin nating pang-multiply? Multiply natin yan ng e raised to jx. Bakit? Para ma-simplify natin yung expression as you can see later. No? Para ma-solve natin siya. So dito, sa left side, itong z, makakaroon ng multiplier na e raised to jx. So that will be z times e raised to jx equals this term times this term, mai-square siya. So, e to the jx squared minus, okay, so here, if we multiply this to e to the 0, will give us 1. Diba? Divided by j2. Okay? Now, multiplying both sides by j2 para mawala yung denominator, magkakaroon ako dito ng j2 times z e to the jx equals this one, I'll just copy e to the jx then squared minus 1. Okay? So, kung napansin natin, nagkaroon tayo dito ng term na naka-square. 'Di ba? Itong term na to naka-square at itong term na ito hindi. So, parang quadratic siya. Right? So, i-rewrite na lang natin yan. Itong term na to, ilipat ko lang sa kabila. Okay? Rewrite natin. So, e raised to jx squared then minus j2 z e raised to jx and then minus 1 equals 0. Okay? So, kung napansin mo, meron tayong quadratic equation. Bakit? Kasi meron tayong naka-square na term, oh. So, para mas maging obvious para sa'yo, simplify natin yan. We let u be equal to this. Para hindi masyadong komplikadong tingnan. We let u be equal to e raised to jx. At i-rewrite natin yan ngayon in terms of u. Para makita mo na itong expression na ito ay isa talagang quadratic equation, no? So, we will have u squared minus j2 times z times this, which is equal to u. Minus 1 equals 0. So, kitang-kita na natin ngayon, meron tayong isang quadratic equation. This is an equation which is quadratic in the variable u. We can solve for u using the quadratic formula. Remember, the quadratic formula, u is equal to negative of b plus minus the square root of b squared minus 4ac all over 2a. Ayan. So, lagay natin dito yung mga values ng coefficients. Dito, yung a natin, coefficient ng u squared is 1. Yung b, yung coefficient ng u is negative j2 multiplied by z. And lastly, yung c is yung constant term na equal sa negative 1. So now, if I use the quadratic formula to solve for u, I will get negative of b will give me j2 times z. And then plus minus the square root of, okay, so if I square this, negative times negative is positive, j times j is negative 1, and then 2 squared is 4, so I will get negative 4z squared, b squared, and then minus 4 times a which is 1, and then c, which is negative 1. Okay? I'm gonna put them inside the square root and divide all of them by 2a. Kung saan ang a ay 1, so that's just 2. Okay? So we can simplify this expression. Gawin natin yan sa next slide. So, itong 2 na to at saka itong 2 na to magka-cancel yan. So, ang matitira na lang ay j times z. Okay? So, u is equal to j, z, and then plus minus. Okay, para naman dito, kung mapapansin mo, ito magpa-positive na. So, unahin ko na to, and then 4 minus 4z squared. Diba? That's the square root of 4 minus 4z squared over 2. We can simplify this, no? jz plus minus. So, kung gagawin kong common factor yung 4, may matitira dyan na square root of 4 times 1 minus z squared over 2. So, if I simplify this, square root of 4 is 2. So, yung 2 na yun at saka itong 2 dito magka-cancel. Kaya may matitira lang dyan na jz plus minus square root of 1 minus z squared. Tapos na ba tayo? No, we're not yet done. Bakit? Kasi yan pa lang yung expression para sa u. And remember, hindi u ang gusto nating isolve. If you remember, ang sinosolve natin is x. Eh yung x na yan ay part ng u. Remember, because u is equal to e raised to jx, then we can rewrite this as e to the jx equals jz plus minus square root of 1 minus z squared. Okay? So remember, the goal is to solve for x. So para ma-solve natin itong x na ito, anong pwede kong gawin? I can take the ln of both sides, right? So taking the ln of both sides, ln of e raised to jx is equal to ln of jz plus minus the square root of 1 minus z squared. Okay? Now, simplifying this will give me jx ln of e, kung saan yung ln ng e ay equal sa 1. So, ang matitira na lang dito, jx is equal to ln of jz plus minus the square root of 1 minus z squared. O, diba? Kitang-kita na natin ngayon. Remember, the goal is to solve for x. So, to get x, we just divide both sides of the equation by j. And remember, 1 over j will give us negative j. So, isulat na natin ngayon. Ano? Yung x na yan ay equal sa negative j ln of jz plus minus the square root of 1 minus z squared. So we now have the expression for finding the inverse sign of the complex number z. Remember, nung simula, ang goal natin is hanapin yung inverse sign ng z na nilet natin as x. So ngayon, ito na yung x. So we now have the formula for finding the inverse sign of the complex number z. That's equal to, copy-paste ko lang to, negative j ln of jz plus minus square root of 1 minus z squared. Okay, so i-analyze natin yung formula. Ang inverse sign pala ng isang complex number ay nag-involve ng ln, no? And what have we learned about the ln of a complex number? The ln of a complex number has infinitely many values, right? Pero dito meron tayong dalawang sets. Ayun, no? Merong positive at merong negative. So kung gagamitin ko itong positive na ito, I get ln of something, right? And that ln of something, again, is infinitely many valued. Okay? So, para sa minus, ganun din. Meron kang infinitely many valued para sa jz minus the square root of 1 minus z squared. However, we can always express the answer in terms of the principal value of the sine inverse of z. Okay? So, para makuha mo yung principal value, then gamitin mo lang yung angle na ang range ay nasa, ang range ng theta para sa principal value. This should be greater than negative pi or less than or equal to pi. Ayan. Para sa principal value ng sine inverse ng z, your theta should be in this range. Okay? So, tandaan natin ha, ito na ngayon yung formula sa pag-evaluate ng inverse sign ng isang complex number that's equal to negative j times the ln of jz and then plus minus the square root of 1 minus z squared. Now, if you want to derive the expression for finding the cosine inverse of z, you do the similar procedure. Dito, gawin mo lang na yung z ay equal sa cosine x. At yung cosine x magiging e to the jx plus e to the negative jx over 2. Wala na yung j, 'di ba? And repeat the procedure until you solve for x. At yung x na yun na yung inverse cosine nung complex number na z, no? So that could serve as your exercise para naman ma-practice yung derivation skills mo. Now, let us have an example, no? Let's evaluate the sine inverse of the complex number 0.2 plus j 0.4. Okay? So, i-recall muna natin ano nga ang formula para sa inverse sine ng isang complex number na z that's equal to negative j times ln of jz and then plus minus the square root of 1 minus z squared. Okay, gayahin lang natin yan ha. So, the sine inverse of 0.2 plus j 0.4 is equal to negative j times the ln of j times the complex number z. Kopyahin ko lang yung 0.2 plus j 0.4 and then plus minus the square root of 1 minus z squared. Okay. Now, medyo komplikado yan. Kaya, para mapadali yung ating solution, gamit tayo ng calculator. Ano? So, we have to make sure that the calculator is in the complex mode. Ito siya ngayon. Paano gawin yan? Mode complex lang po. Mode complex. And then, dapat naka-radian mode yan. Paano gawing radian? Shift and then set up. Okay, piliin mo yung 4 for radian. Ayan. So, complex at saka radian na tayo. So, pwede na tayo ngayong magsimula. Unahin nating i-evaluate yung nasa loob ng parenthesis na to. So, ito muna, j times this. Okay, so pwede naman gawin natin yan ng manual, no? Mano-mano na lang. So, copy ko lang to, negative j times ln of, okay, this becomes, j times j is negative 1, kaya magiging negative 0.4 plus, ito, 0.2j or j 0.2 and then plus minus. Okay, square root of, ayan, kaya bang kumuha ng calculator ng square root? Hindi rekta. Kaya dapat 1 minus, yun munang nasa loob ng square root yung ating evaluate. 1 minus 0.2 plus j 0.4 squared. Kaya ba itong gawin ng calcu? Yes, actually, pwede yan sa calculator. O gamit tayo ng calcu. So, 1 minus, kopyahin mo lang to, 0.2 plus 0.4i. Ayan. Tapos, naka-square siya. Ayan. And then, equals. So, may makukuha tayong sagot. Ano? Yung sagot na yan, isave natin kasi gagamitin natin yan later. Okay? So, kopyahin ko lang ulit ha. Negative j, ln of negative 0.4 plus j 0.2. Then plus minus square root of, ano nga yung sagot sa calculator? 1.12 minus 0.16. So 1.12 minus j 0.16. Okay. Yung pagkuha ba ng square root ay kayang erekta sa calculator? No. Kaya kinakailangan, yan ay i-express mo pa sa exponential form. Kopyahin ko lang to. Negative j, ln of negative 0.4 plus j 0.2 plus minus. O paano gawin sa calcu yung square root? Since naka-store na to sa calculator, paano ba kumuha ng square root? Diba? Yun ay square root ng r and then e to the j theta over 2. Diba? So, since principal value naman ang kailangan natin, hindi ko na ilalagay dito yung plus 2k pi. No? Yan na lang. Theta over 2. So, paano natin i-evaluate yan sa calcu? Madali lang. No? Madali lang. Kasi nakasave na siya sa calculator natin. So, square root lang ng absolute value, ito yung absolute value, ng A. Kasi doon nakastore yung complex number mo. Tapos yung angle sign, shift, ito. And then, yung angle, kasi i-divide natin sa 2. Yung angle, that's the argument. So, to get that angle, shift complex, and then piliin mo lang yung 1, kasi yun yung argument. Argument of what? Argument of A, kasi doon nakastore yung complex number mo. And then, i-divide mo siya ng 2. Ayan. So, pag pinindot ko yung equal sign, in-evaluate ko na yung square root ng complex number. Okay? Eto siya ngayon. Lagay natin. Kopyahin ko lang ha. We have negative j, ln of negative 0.4 plus j, 0.2 plus minus, ito na yung sagot ngayon, 1.061 minus j, 0.0754. 0.0754. Okay. So, kinakailangan muna natin itong i-evaluate bago natin siya kuhanan ng ln. Ano? At dahil itong sagot na ito ay gagamitin natin, i-save natin yan ha. Shift, store, lagay natin sa B. Okay? Now, unahin ko muna ito. No? Yung negative 0.4, negative 0.4 plus 0.2i, kinakailangan ko siyang i-add. Unahin ko yung addition ha. I-add ko siya. Doon sa sagot dito. Eh, di ba nakastore yan sa B? So, alpha B na lang. Alpha B. Okay. And then, equals. So, meron tayong makuhang sagot. 0.661 plus 0.1246i. Okay? Sulat natin yan. Sa kabilang slide na lang. Kopyahin ko lang to ha. Negative j ln of. So, the sine inverse of 0.2 plus j 0.4 is equal to negative j times the ln of yung nakuha nating sagot sa calculator. 0.661 plus j 0.1246. 1246. Okay. So, itong kukunan ko ng ln, isa-save ko yan sa calculator. Shift, store. This time, ilagay ko naman siya sa C. Okay? So, pag kumukuha tayo ng ln, remember, ln of the complex number z is equal to ln of r plus j theta plus 2k pi. Kasi nga multi-valued yan, di ba? So kung principal value lang ang ating kukuhanin, tatanggalin ko na yung 2k pi, no? So kailangan i-express natin ito sa kanyang polar form or exponential form. So negative j ln of, ano ba ang exponential form niyan, no? Shift complex 3 para mapalabas natin yung exponential form niya. So that's 0.6726 ln of 0.6726e to the j. Ito yung angle niya in radian, 1863. 0.1863. Okay. Pag in-evaluate natin to, magiging j times, ano nga ba ang ln of the complex number z? That's ln of r. ln of this, 0.6726 plus j, ito yung theta niya, 0.1863. Okay. So, gawin na lang natin sa calculator para mabilis. Ano? So, meron tayo ngayong negative I times ln of this. Okay? Ano ba to? Yan yung absolute value ng complex number na nakastore sa C. Di ba? So, gawin na lang natin yun. Shift, abs, para hindi tayo magsulat ng number. Absolute value nung alpha C. Ayan. So, ln of, ito yung R natin ngayon. ln of R, and then, plus, ito yung angle niya, di ba? Argument yan. No? Paano i-recall yung argument? Shift, complex, arg. Ayun. Okay. Argument ng C. Ito siya. Tapos, imumultiply lang natin ng I. Kasi may J doon. Diba? And then, lagyan mo lang siya ng parenthesis. And then, equal sign. So, meron na tayo ngayong sagot. Ito yung sagot natin. 0.1863, 0.1863 plus J, 0.3966 plus J, 0.3966. So, ito na ngayon yung inverse sign ng complex number na 0.2 plus J 0.4. Okay? So, hindi siya ganun kadaling kuhanin kasi nga medyo matrabaho siya. Ano? Marami tayong ipe-perform na subsequent procedures. So, kung gagawin mo yan ng mano-mano, medyo mahirap. Medyo matagal siya. Kaya, ginamitan lang natin ng calculator. Pero kahit nag-calculator tayo, tingnan nyo naman, umabot pa tayo sa 3 complex numbers na isinave sa calcu bago natin nakuha yung sagot. Diba? So now, marunong na kayong kumuha ng inverse sign ng isang complex number. So I hope may natutunan kayo dito sa video na ito. If you like this video, don't forget to hit the like button and share this to your friends who are also studying advanced math. Kasi naman, sharing is caring. Bye!